Hello, hello, hello. Welcome to my next live stream, the third in the series this week. Again, as I said before, there is a bit of a delay between what I say and what comes out of your mobile phone or your computer. So please just give me if you can type in the chat and let me know you can hear me and that everything's working, that would really help me. And I'll just prepare to get everything on the screen. There we go. So there seems to be some sound coming out, so that's good. Stand by, stand by. Let's see what's going on. There we go. My text on the screen seems to be working. So if you have any comments in the chat, I can bring them up on the screen. I can see 2 people are joining us so far. Fantastic. Oh, there we go. So we've got Mark. Hi, Mark. Great to see you. Thank you for coming along and coming to the third session. I've got Pa. It sounds fine. Fantastic. Thanks, Per. Appreciate that. Fantastic. Okay, well, let's get stuck in then. So this is the third live stream of a review of a service inquiry investigation report into the grounding of the HMS Astute in October 2010, so 15 years ago now. And essentially what I'm doing today is I'm going to try and push through the last, I say I'm going to try, I've got to push through the last the last few pages of the report today, so we're going to get it all done. It could be a long stream, depending how fast I talk, but we need to get through it today because tomorrow we've got a Halloween party and I can't stream while there's kids and people running around. So there we go. So I hope you're in the long run today. Fantastic. So we've got a few other people. We've got James. Hi, James. Great to see you. Thank you for coming along. Thomas. Hi, Thomas. Great to see you. I can hear you in the southwest desert of the US. Well, fantastic. Well, if you'd like me to come to the desert, give you a hand, give me a shout, and I'll be sure to come over. Mark says, I will be rejoin as I do not see or hear anything. Okay, Mark, see you in a moment. And he's got it now. Fantastic. Great. Well, let's get stuck in then. So we need my amazing green screen technology. So there we go. Look at that. Fantastic. I'm looking a bit pale from the lighting. So should we increase that? There we go. Make it a bit lighter. A little bit of green tinge, you know. Right, okay, so as I said, this is to do with the HMS Astute submarine accident grounding off the Isle of Skye in Scotland in October 2010. Essentially where we've been so far, as you can see, there's the overview of the investigation report. So far we've been through the first and part of the second section. So the first section is the narrative of events. We've been all the way through that. Excuse me. In fact, actually, before I continue, I need to press record, so just bear with me a second. There we go, now we're recording. So yesterday and the day before, we started going through the narrative of events. We got all the way through that on Tuesday, and then we started yesterday going through the analysis of the events, the contributing factors. And we commented a little bit about how a cast accident analysis approach to investigating this accident would generate some different kind of perspectives on things and would help us to at least manage our tendency to talk in terms of hindsight bias. We also talked about responsibilities, and where we left it yesterday was talking about, there we go, this bit here. So we left it yesterday talking about safety responsibilities and how they're allocated to controllers in the control structure model. Now, of course, you know, a standard hierarchical organization, they will always say, well, the guy or girl at the top, they are ultimately responsible for whatever, you know, their organization is doing, whatever the operation is, whatever the mission is. Now, of course, that is appropriate, but in the context of, do they actually have a control structure that has controllers, actuators and feedback and the ability to influence the control process such that they can actually be held responsible? You know, do they have the capability and resources available to them? And if they don't, then is it really appropriate to essentially point fingers at them and essentially blame them for, you know, not fulfilling those responsibilities? So there is a bit of a conversation to be had there, and I do recognise and respect, you know, the nature of this organisation and that it has to have a hierarchy and there has to be, you know, accountability. But, you know, with accountability should be capability. And if the individuals involved and the control structure involved does not have the capability, is it really appropriate to make them the fall guy, so to speak? And that's a standard safety conversation we have everywhere. But again, it's important. You know, the whole point, the whole the main concept behind STAMP is about the concept of a control loop and a control structure, and whether that control structure is equipped and capable and actually capable of fulfilling safety related responsibilities. And if it's not, as has been shown in this case, then we shouldn't really be surprised that we're having accidents. But anyway, enough of that. Let's get stuck in. So we've got a few more comments. Mark says green tinge just in time for Halloween. That's right. Yeah, you'll see my teeth grow later on. Right then, there we go. So so the last part of this report, there's sort of 3, 4, 5, 6, 7, 8 pages to go. So this part is the detailed analysis of the navigational plan. Then we've got the detailed analysis of the execution of navigation. We've got something about records, something about equipment. There we go, equipment, damage that occurred, and then the first of class issues. Because of course this is the first of class, the Astute class submarines, HMS Astute. And of course with anything new that's as complex as this, these things are mind-blowingly complex. The safety case, the safety assessment for these things, having worked in similar, is just mind-blowingly complex compared to any of the other systems I've previously worked on. These things are absolute, behemoths. And of course, because they're so complex, both the things themselves, the organisations operating them, and of course the design organisations, the test organisations that are involved, the safety process, the engineering process behind this, it's just absolutely phenomenal. Okay, so then findings and then finally recommendations. So let's get stuck into here. In fact, before I get stuck in, are there any questions that you've got hanging over from the previous 2 live streams, or is there anything you'd like to add before we get stuck in? And I'll just sneakily get a quick drink. There we go. I'm so pleased my technology's working today. Apart from LinkedIn Livestream decided to change the access codes before I tried to go live again, which seems to be a common theme with this. But anyway, right, here we go. So, excuse me, detailed analysis of the navigational plan. Just as a reminder, I'm not an expert in the operation of these things, so some of the things I say might be complete nonsense, and you're welcome to call me out in the chat and correct me. So navigational intentions for the boat transfer were not clearly defined in night orders. Excuse me, I've still got a cold. I apologise if I sound bugged up. So let's put night orders up here just because, these sound distinct from the COC orders, the full set of rounds, the emergency operational procedures. These are some night orders. Now, of course, I've added them as a controller, and they're not strictly controllers in their own right, because they are not something that has the ability to make a decision or effect a change on a control process. But they are things that will influence human beings and their decision making and their mental models. So that's why I like to include them. Because of course somebody might, behave in a certain way because the orders said to do X, Y, Z. Or they might have misinterpreted the orders as an example. So it's always good practice to include those just to sort of help with the creative thought process. Excuse me. So, and the specific conduct of this transfer was not discussed between the CO and the NO. I'm presuming NO is navigation officer, so let's go over here. Have we got the navigation officer already in our list of controllers? NO. I'm sure we had it somewhere. But yeah, there we go, navigating officer. So we'll make that an NO. And they are obviously somewhere. I don't know if they're in the control room or in their own location, but we'll stick those there just to the side so we don't forget. Right, where were we? Okay, so navigation officer. There was no evidence of any planning in the NO's workbook or notebook. I think we mentioned that the other day, notebook and workbook, didn't we? I think that's what this must have been here. NO, notebook, workbook. There we go, let's stick that in there and put it next to the navigating officer. There we go. So, understanding of the plan differed between key players. The CO, XO and NO understood, that the submarine should, on reaching the grid, reduce speed to whatever and manoeuvre as required within the box for the boat transfer, optimizing for prevailing conditions. Okay, so yeah, just to focus on that for a moment, the understanding of the plan differed between key players. So if we go back to our standard jigsaw piece, what we're saying is that, let's just delete that bit there. So if their understanding is, their understanding is essentially a belief or mental model about the control process or the future changes to that control process or other things going on with that control process. So if we're talking about the movement of the submarine, then of course the NO, the XO and the CO, they'll all have their beliefs, their mental models about the submarine and the way it's going to be operated. And of course if there's differences in that understanding, those beliefs, then that can lead to potentially unsafe or contributory control actions being provided by any one or all three of those. And that will influence their decision making as well. So again, just to reinforce this point, one of the core concepts of STAMP is the control loop, these jigsaw pieces. And if we can embed that in our mind, whenever we're reading a document or talking to people, interviewing people, try and have a think, what is the control loop that we're actually talking about here? What is the control structure? What are the beliefs or mental models that this controller has? How does that affect their decision making and ultimately the control actions that they provide? And of course, what feedback has led to those beliefs? And if there is no feedback, that obviously that is an explanation as well. So going back over here then, just zoom back in. There we go. Should be able to see that okay. There we go. The Petty Officer of the Watch, see I remember now, look at that, fantastic, it's only taken 3 days, was that the submarine was to proceed to the southeastern boxes within the grid as this had been conducted previously. So again, that's a mental model, some beliefs on the part of the Petty Officer of the Watch and their expectations of what's going to happen. So that mental model, those beliefs, will shape the way that they make decisions. So if they're getting feedback about the situation that matches their mental model, which is not what it's supposed to be, then of course they're not going to call out and say, hey, there's something wrong. And vice versa, if they've got a belief about how things are supposed to play out and they're not playing out that way, of course, they can then start providing control actions or harsh feedback, so to speak. Firm feedback, I should say. As this has been conducted previously, in order to reduce transfer times, the officer of the watch believed, there you go, there's that word believed, so mental models everybody, that he could conduct the transfer anywhere within the boat transfer grid, provided that it was a good location for wind and had enough sea room in order to complete the transfer. Okay, so that's quite interesting because like we were talking about yesterday, there are actually some constraints from the procedures on how they conduct those boat transfers. And I'm just wondering whereabouts that is. Let's have a look. Bridge preparation, use of radar, planning. Yeah, it was to do with these procedures over here. Where is it? I think it must be that box there that's been incorrectly got a P in it. But there were some procedures mentioned or some ways of doing the tasks which they should have followed, but didn't for various reasons that we touched on yesterday. Situation awareness, slow astern, ship control, failure in communications, boat transfer grid, generic plan, standing orders, that's about the echo sounders. Yeah, there was some mention yesterday. I can't see it. We'll have to go and dig it out. I won't do it now. Let's keep moving. Both charts were checked against the November Papa 113B. and found to be up to date for chart corrections. It was found that the chart correction page, which includes the correction state for chart 2498 in folio 5, was missing. So there's some missing feedback perhaps, or missing critical information. However, the duplicate chart in the local folio was viewed and both charts were at the same correction state. I don't really know what that means. It doesn't quite make sense to me. It sounds like there's two charts and that they were supposed to be at the same standard, but the standard was different. The standard was not correct. It was found that the chart correction page, which includes the correction state so the correction page was missing. Oh, right, okay. So in a lot of documents that are safety related, they typically have an amendment or corrections page at the beginning, which will tell you what the state of the various pages in the document are. So when various bits of it get changed, because especially if you've got a large document, you don't want to be reprinting the entire thing. It gets a bit ridiculous. So you'll insert and remove certain pages. And so if that correction page was missing, that suggests that, it could be just a simple administration error, or it could hint at something more significant. And when we're dealing with config controlled information that's safety related in nature, we absolutely must have discipline about making sure those things are correct. And if things are missing, it gets reported and dealt with appropriately. Okay, so November... Where is it? Delete. Let's just move that out. November Papa 133 Bravo. I don't know whether that's relevant, but let's capture it anyway. Let's capture it anyway, because we can always chop it out later on. Like I said yesterday, this is a bit of an art, and it's a bit of an art to start with when you're first figuring out how to do control structure models. And especially if you're doing it as part of a safety investigation, you don't necessarily know what you don't know. You don't know whether it's going to be relevant or not to the remainder of the analysis, but it's worth capturing it just in case. So let's put that over here somewhere, and we'll put it next to the charts. Where's the charts? We had some charts, didn't we? Where have they gone? Where's the chart? Where's the charts gone? We had some charts. They've disappeared. Oh, there they are, look. There's some charts. We'll stick that next to there like that. There we go. So both the plot and bridge charts, so they're two distinct things, had an inked in LDL. I think that's to do with the depth, the line of depth around the shore or obstacles at the 15-metre contour. No visual or radar safety was annotated on the plot whatsoever. So I'm getting an impression they could have physical plots and charts, plot and bridge charts, or they could be on the digital systems. I'm not sure. But let's just make a note over here that we've got a plot chart and a bridge chart. And I'm guessing that they are two distinct things physically, and obviously they relate to wherever they need to be. So you'll have a plot chart that is under the control of the plotter, the plot person, and then you'll have a bridge chart, presumably up here somewhere. So let's just put that over there. There we go. I'm making some assertions there, so if we had an SME to explain that, that would be helpful. So we've got some comments. Chris. Hi Chris, great to see you. Thanks for coming along and contributing. You are right, navigation or navigation officer, often referred to as nav. Fantastic, thanks for that. So some clearing bearings were sighted on the bridge chart, covering the coastline in the vicinity of the grounding, but not to the north of the boat transfer grid. Actually, let's just give you a quick recap of this grid from Tuesday. So this is the reconstruction of the navigational track with the boat transfer grid placed on it. And so north of the boat transfer grid is sort of around this area. Excuse me, there we go. Yeah, so let's continue. So these visual clearing bearings were based on edges of land and islands which would have little utility at night. Yep, there is a lighthouse though in that area, I think. In all but the best conditions or by day in reduced visibility. The bridge chart presented as evidence to the service inquiry team also detailed a pilotage plan to the buoy in Bradford Bay. Clearing bearings, wheel over points and distances to wheel over were clearly marked, as this was a proposed plan for the submarine once she had been refloated. This seems to mix up detailed analysis of the navigation plan before the accident or the incident, and then post-accident. I don't know why they've mixed that together. Maybe that's just the way that they've written it. Again, I don't want to sound too critical of the investigators and the people that wrote this investigation report, because it is difficult, it is hard. So please, if you're watching this, please don't think I'm tearing strips off of you and being too critical. I'm not trying to do that. I'm just trying to bring out some points for thought and conversation, so that we can all learn and do things even better in the future. So clearing bearings, wheel over points and distances to wheel over were clearly marked, as this was the proposed plan for the submarine once she had been refloated. Right, okay, so of course the investigators will be looking at these things post-accident, post-recovery, and so they're commenting on what they've identified as part of the report, the investigation. The SI team have some reservations as to whether the clearing bearings displayed on the chart were actually displayed prior to the incident. Okay. And were not in fact annotated as part of the planning for the Bradford Bay pilotage. No evidence of a no-go sounding was displayed on the chart. Okay, I don't know what a no-go sounding is, and this annotation bit and this concept of display and this concept of no-go sounding display, that indicates to me that this is a computer system of some description, and that it has some kind of human-machine interface that provides information to the users, and in this case, whatever this no-go sounding thing is, I'm presuming that's to do with, sounding of the depth of the water maybe, and that it provides an alert to say don't go in that area, or it provides an overlay that says don't go in that area. I don't know, I'm just guessing, I'm postulating. Please, you're welcome to correct me in the comments, but don't share anything sensitive inadvertently. So let's just look at that again. So we've got the display of the chart, and we've got the annotations on the chart, and then we've got this no-go sounding display on the chart. So let's just go over here then. So this is the chart here, and I'm anticipating that there's some kind of submarines navigation equipment of some description, and this, oh no, that's not, I didn't want to do that. There we go. Let's bring that to the front. So there is some kind of chart displayed on it, and that information should provide feedback to the people who need to know that navigational information. There we go. So zooming in, there we go. So the plot chart displayed an inked in boat transfer grid. This had and when it says inked, I'm presuming if it is a digital system, it's not literally, scribbled on with ink, it's digital ink, so to speak, or unless they do use genuine paper charts and ink it on. This had additional boxes. Oh, there's pencil, there we go, so there's pencil. So I think that's probably a physical. So they use ink and they use a pencil. Amended to the southeast of the box, Foxtrot 7, Golf 7, Hotel 7. So let's just look at this. There we go. So number 7. Oh, so where's number? Oh, these are number 7. There we go, look. I'll just highlight those so you can see them. There we go. That's the area we're talking about. And of course, they dropped straight out the bottom of that and then got stuck. Okay. The boat transfer grid on the bridge differed from that on the plot chart. Oh dear. That is not good. Boat transfer grid differed on the bridge chart, the plot chart, in that the pencil amended boxes, and the inked in boxes, Golf 5, 6, H5, H6 were omitted. So let's just look at the plot. Golf 5, 6. Oh, so these ones. That's interesting. So, and which one was that one? That was the... So the boat transfer grid on the bridge chart differed from that on the plot chart in that the pencil amendment boxes and the inked in boxes were omitted. So those boxes were not on the bridge chart. Okay. So there's a question there in terms of the control structure. And I always sort of emphasize to people, when you're thinking in terms of control structures, especially if we're doing incident investigations, think about that we're exploring the control structure that existed on the day, that is essentially the operational control structure. But that structure itself is supported by what you could argue support control structure, which is intended to feed the operational control structure with current and correct information or resources, for example. So in this case, we've got some charts. We've got a bridge chart and we've got a plot chart. So what is the control structure to make sure that those charts are complete, correct and up to date, and that they don't diverge from each other, or that they don't miss important information that they both should have? Now, I don't know the answer to that. I don't know if that is a submarine activity, somebody on board or a team on board does that, or whether it's an off-board team, whether it's a manufacturer team, or there's a special charting office, something like that. But that, as an avenue for inquiry, that is certainly something I would expect to be looked at in some detail, especially if they're digital charts. Because if you've got issues with software and data and networking as well, or maybe even cybersecurity, let's really push the boat out there. Has somebody tried to undermine the operation by, putting faulty chart information in there? I'm just playing devil's advocate a little bit there, but I'm sure you can get where I'm coming from. Okay, we've got a few more comments there. Let's have a look. So Chris says, I think a no-go sounding may be a depth sounding where it's too shallow for the boat to transit through. Okay, thanks for that, Chris. There was a mention yesterday that the sounders, where is it? Sounder. Where is it? Use of radar. Actions by the... They turned the sounders off, or they weren't turned on early enough. There we go, the echo sounder. So the echo sounder, if that's related to this function, was only turned on at 0628, and it should have been turned on earlier, but for whatever reason it was not. And it does say in the report that function was the responsibility of the officer of the watch, going up the top. But it doesn't explain why they didn't do that, or why it's just, who else is responsible for that. Because I wouldn't like to think the officer of the watch is responsible and has to do everything. I'd expect that that's distributed amongst the team. So thank you for that. Who else have we got? So Charles, hi Charles, thank you for coming along. Prior American Submariner here, fantastic, good to see you. Sounding sounds similar to what we call a red sounding, which when received triggers immediate action, i.e. back down the boat, reduce depth, turn, etc. Okay, no, thanks for that, Charles, that's great. Chris says, when I was at sea, there were physical charts with pencils to annotate the key information. Great. And Charles, combining all chart data to a single chart has always been an issue, and it's manually tedious and prone to error. Okay, that's fantastic, Charles. So we've got some explanation there. We've got some context around why it would make sense. That's brilliant. Thank you. Excuse me. Right, there we go. Right, so the plot displayed a nav track which entered the boat transfer grid at box Delta 1 on a course of 130 and finished on the eastern edge of Gulf 5, western edge of Gulf 6. Distances to run on this nav track were wrong, as admitted by the navigation officer when questioned. This nav track was not annotated on the bridge chart, although a track from the Rona range to the buoy in Broadford Bay was marked on the bridge chart as part of the subsequent plan once the submarine had been refloated. So Rona Range, that is the Butech Underwater Test and Evaluation Centre range where the submarine was doing some operations in the previous hours, previous days. And so I'll just quickly show the map again. So this is northwest Scotland. There we go. The range is located in this area here. The incident occurred down here. And of course, they'll have had charts to navigate from over there, from the range and into the inner sound to do the boat transfers in this area here. Great. So bubble times were not annotated on the plot chart, nor any clear chart notes and instructions as to when to reduce speed and prepare for the boat transfer. Tidal diamonds had not been marked on the transfer, not been marked up for the transfer on either chart. Yeah, so that's quite interesting. I'm not quite sure what bubble time is. If you want to tell me in the chat what that is, that would be helpful. And then the same for tidal diamonds. I think I can guess what that is. That's to do with the direction and times that the tide's likely expected to change. And they're generally like clockwork. So, yeah, but those not marked on the charts. Again, what is the control structure on making sure those charts are up to date with the right information and that they've been verified and validated before being put into use? And again, I'm not pointing fingers here, but they're the kind of questions that I would ask using CAST as a basis for my investigation. So Thomas Murray says, what are bubble times? Yeah, exactly. That's what I'd like to know. I would jump on Google and start typing, but I don't want to go inadvertently. You never know what might come up in Google, and I don't want to get to do something really silly or embarrassed and get my account blocked on LinkedIn. So if you'd like to do that and type in the chat what it is, that would really help. Excuse me. Right. It is the view of the service inquiry team that the navigational plan falls short for the requirements laid down in BR 45 Volume 1 and is a contributing factor to the grounding. Yeah, I agree with that. But it's not just the navigational plan. There's more to it than that. Why were those charts not controlled in a way that would be appropriate? So navigational plan. Let's just go over to the control structure and have a look. I think we mentioned it yesterday, didn't we? Navigational plan. Navigational plan. Where is it? Maybe we didn't write it down. Oh, excuse me. Right, what I'll do is I will put navigational plan as a controller, and I'll put it down here somewhere. And navigational plan. There we go. And then planning activity. Then I'll put chart update. There we go. Fantastic. Somebody is writing something. Oh, here we go. This is a big comment. Let's see if it fits on the screen. I don't know if it's going to fit, so just bear with me a second. So we've got a bit of it. Right. So Mark has kindly said, I'll get it on my screen fully. While bubble time isn't itself isn't a specific procedure, it might be a jocular or informal phrase the crew uses to refer to the moment a significant angle is put on the boat, especially during a dive or an emergency surface, which creates a rapid up bubble. Yes, I recall from one of my favourite films, The Hunt from Red October, they talk about up bubble and down bubble. So yeah, I'd expect that that's probably to do with depth. Thomas has kindly said, from Google, submarine angle, the most common operational reference to the bubble relates to the angle pitch of the submarine on the water. The term originates from the bubble in a bubble level clinometer, a gauge that indicates the submarine's vertical trim. Orders like up bubble or down bubble, there we go, tell the dive plane operators to angle the ship up or down, which changes depth or maintains a specific depth at a certain speed. A zero bubble means the submarine is at an even keel. Oh, there we go. Chasing the bubble is a term for diving officer or pilot trying to get the ship to a level angle or having difficulty maintaining a steady angle. Oh, that's fantastic. Thanks, guys. This is great. This is a proper team effort. This is brilliant. Thank you. And Chris says, don't know, never heard of bubble times in my short service on boats. The bubble used to be how we referred to the attitude of the boat. Down bubble equals diving. Bubble times has me confused. That's all right, Chris. Fantastic. James, thanks, James. We've got tidal diamonds are often printed on the paper charts and supported by tables, again, on the chart. However, they refer to high water, so it's normal to write high water times for the date on the chart. Yes, and there is a mention earlier on of those times, and also the amount of variation in the water depth. I mean, I think it was like 5 meter variation or something. So yeah, thank you for that, everybody. That's good teamwork. There we go. Right, so where we get to now? So that's 1 and a bit pages. Right, so let's talk about. In fact, I'll just have a quick drink. There we go. If there's any questions or anything like that you got, just stick them in the chat while I have a quick drink. There we go, fully refreshed. Still a bit bunged up and a bit snotty, but there we go. Right, so detailed analysis of the navigation. In the execution of the navigation, the fixing routine was being conducted by the petty officer of the watch. GPS was being used as the only method of fixing the ship. Okay, let me just stick GPS. Where's a little box? Actuator. Is it actuator? Is it a sensor? Or is it some feedback? Let's mark it on here like this. Feedback, GPS, data, time. I have a bit of a funny sort of concern about GPS. Because if somebody spoofs that information, how does that affect navigation and timing functions? And we see this a lot over Eastern Europe, past Poland, towards the Russian-related states. Spoofing of GPS affecting navigation of aircraft and things like that. If you have GPS data and time feed into your systems, how reliable and dependable it is. And I'm not going to comment because I don't know the details and it wouldn't be appropriate for me to say. But thinking about that as an input to your control loop, you'd want to make sure it's protected or high integrity, however you might do that. Okay, so where are we? Let's zoom in a bit more so you can see. So we've got GPS was being used as the only method of fixing the ship, bar 1 3-point visual fix at 0600. Soundings were not being tied in as ever. Oh yeah, soundings. I think you mentioned that, didn't you, Chris? Were not being tied in as evidenced by the fact the echo sounder trace was started at 0628. So let's have a think. Let's go down here. So oh no, not that. So fixing the boat, or did it say ship? Fixing the ship activity. So that, excuse me. So that requires feed information from the GPS, that activity. So I'm making that box, whilst it is a box, you could say, well, is that a controller? No, it's not a controller. I'm just including it as an activity, a bit of a reminder that fixing the ship includes that data, but it also includes data from the echo sounder, which, there we go, I'll put that in there like that. And we know that wasn't turned on until 0628. And this one, the last time this was done was at 0600. Last fix. Not fix, what did they call it? GPS was, method of bar 1 3-point visual fix at 0600. So there was a visual fix from somewhere. So who did the visual fix? So we need a sensor, and we'll call that a visual fix. And I'll put that over here just because it's grouped together logically. And I'll stick a feedback loop on there to go all the way down here to this activity called fixing the ship. And again, I keep labouring this point, but I just want to put your mind at rest. What we're building here is it's a creative process creating the control structure model. And of course, we're trying to capture a lot of information and ideas and prompts to remind us to think about things. And it's a good idea to just capture it in the way that makes sense to you, and then refine it and make it look nice and presentable for an audience later on. I wouldn't suggest you show the work in progress of one of these models to your audience, your stakeholders. This is your model that you're creating as the modeler, the analyst. So we've got a few people talking. What have we got going on there? Let's just have a look. So Thomas says, I thought that submarines used an additional tool beyond GPS. These are other systems classified per my understanding. I'm sorry, Thomas, I can't possibly say. I can't possibly say about a particular topic. Charles says also, was it military GPS or commercial GPS? I don't know and I can't say. Commercial GPS has an intentional location error in it, whereas military GPS location data is much more accurate. Could be meters. I'm not saying anything about that. Boats use multiple sensors to fix position, including Mark 1 eyeball when on the surface close to land. Yeah, we've got the Mark 1 eyeball. So that is the visual fix. So Mark 1 eyeball. We don't know whose eyeball that was, by the way. I'm not sure. Arguably, it probably is the executive officer, but we don't know that to be the case yet. And it did say that it was 0600 that Mark 1 eyeball was used, and I'm not sure that was the executive officer. I think they were still fiddling around getting their secondary navigation position sorted out. So I don't know. There's a bit of an ambiguity. Either there's an ambiguity in the information in the report, or an ambiguity in my understanding. So that's fantastic. Charles says, with regards to fixers, subs use a combination of MIL GPS, commercial GPS, visual fixers, soundings, and inertial navigation. Fantastic. Thanks, Charles. There we go. So we talked about that, and there was no record of soundings recorded in the fixing log because no recordings of soundings in the fixing log, which is a contravention of astute class standing orders. There we go, everyone. There's a contravention there. Okay, so why was there a contravention? Why did it make sense for the people to do that? What was going on? No recourse was made to the use of starboard optronics. I think we've included that already. Right, okay. So this visual fix was probably the optronics. Optronics, maybe. Not physically somebody standing outside in the dark looking at it. It was probably through the optronics. I'm guessing. Optronics mast to tie in visual bearings. 1009 radar. Excuse me. Was not being used. So 1009 radar. Where is this? 1009 radar. Let's just put this over here. 1009 radar. Not used. Available. But not used. Fantastic. So again, why did it make sense for them? Did they know it was available and to use it, or did they not know it was available and that's why they didn't use it? Why did it make sense for those involved, the controllers involved, to behave the way that they did? In their context, in the context of what they were doing at the time and the challenges. So Chris has asked, is that how they refer to the periscope now? Possibly, yes. This boat has many weird and wonderful sneaky beaky things sticking out the top. There's a picture of it somewhere. Where is it? There we go, look, mate. So there's loads of stuff sticking out of there. I'm not going to point to what's what. You probably get that on Google, but one of those is an optronics mast. And I think that's in place of a traditional kind of periscope. I don't want to say too much more than that because I can't speak. I don't know. Okay, right. Let's have a look. The officer of the watch, Lieutenant Commander, had taken charge of the ship. So that's a formal sort of state, and therefore had responsibility for the execution of the navigational plan. Okay. So does that mean that they don't have I'm plucking at straw, picking at things here. But does that mean that they don't have responsibility for generating the navigational plan? Not sure. As evidence in the fixing log, the correct navigational responsibilities before taking the watch were not conducted in accordance with astute SSOs. Oh, right, okay, so that's interesting. So what I was saying on Tuesday is during this sort of time window of about an hour before the collision, there was a change in the watch, change in the personnel involved in the control structure. And so they would have had to have handed over their responsibilities and the state of whatever it is that they're doing for their particular role. And then the new people would have continued that. And so this, in fact, I'll just quickly jump back. So when we're doing a cast accident analysis, one of the things that we specifically focus on is changes and evolution in the control structure. And so if there is a watch handover, switchover, of course that changes the control structure, the content of it, and the mental model states of all the people involved, and the control processes that they're dealing with. So if they don't get a good handover or don't complete tasks which were begun before the handover, of course, the handover explains what that might be. So it's critically important that those handovers are done, and that when people are doing tasks, they're able to relay the state of that task to the next person so that they can continue the work. Handovers are classic, causes of accidents in many domains. So where were we? So there was a handover, and the correct navigational responsibilities before taking the watch were not conducted. So who is responsible for that, conducting that stuff? And when I say responsible, I'm not trying to point fingers and say, oh, it's you, it's your fault. No, what I'm trying to establish is, what does the control structure look like and how has it evolved? Involved. There we go. It's difficult to write with the mouse. There we go. Right. Astute standing orders, we've already got that in the list. We've already got navigational plan in the list, so we don't need to stick that in again. In that he did not put a fix on a chart, so that's a contributory control action. Make notes on the navigational plan to take it to the bridge, and did not provide the petty officer of the watch with any direction on navigational intentions. Oh, we've got a few comments there. Charles Chuck says he has to run. This was fun. Thanks, Charles. Thanks for coming. We'll see you on the next one. And then Chris says, navigational plan often made by the nav and nav's yeoman. Okay, then briefed to the command team in the build-up to the evolution. Thanks, Chris. That's fantastic. There is no record of the responsibility for the execution of the navigation being passed to another officer. That's interesting. Excuse me a second. Without an so there's no record of responsibility for the execution of the navigation being passed to another officer. I mean, that doesn't necessarily mean it hasn't happened, but, it's important to record these, log these kind of things. So the question is, well, who are those people? Did we establish that as part of the investigation? Maybe it'll be established in the next couple of paragraphs. Okay, so without an operational radar or bridge chart, the ability of the officer of the watch to execute the navigation from the bridge was significantly degraded. Okay, there is also no evidence to suggest the fixing routine and navigation was being robustly managed by the officer of the watch from the bridge. By his own admission, the officer of the watch below did not provide thorough supervision of the plot and the fixing routine, stating in his interview that he had only 10 to 15 hours experience as the surfaced officer of the watch below. Okay, well that, excuse me, that explains a lot, doesn't it? And again, that's not a criticism of the individual. The control structure should be robust enough to when they're doing training or introducing people with lesser skills, the control structure should be robust enough to recognise that and make sure that they are taken care of and that they can't drop the ball so catastrophically. So why didn't the control structure do that? I don't know. It's not clear so far. Less navigational so the POO, the Petty Officer of the Watch, presumably had more navigational experience than the below Officer of the Watch. The Navigation Officer was nominated as the Casing Officer. So there's another role, another responsibility. Pardon me, so let's go over here. We have a casing party somewhere. Where are they? We wrote them yesterday, didn't we? Casing party. Casing party. Where is it? There it is, casing party. Right, let's stick those over here somewhere. Stick them there. And there's a casing officer. There we go. Officer, who was also the navigation officer. Now, I don't know about you, but why would you have somebody that's already doing such an important role, navigation, also doing another really important role? I understand there's not that many people on a submarine. I totally get that. But there's a control structure for safely navigating the submarine and avoiding collisions and grounding. And then there is a role in another control structure for performing the mission of whatever the casing party are doing and making sure the casing party is safe. So, having one person doing both of those, you're sort of joining those control structures together and potentially undermining the safety of both of those control structures, both of those processes. Again, I don't know the details, so please, if you do know, give me some abuse in the comments and let me know, correct me. But it's not appropriate to pollute those two control structures. So we've got a comment there from Mark. I don't think it'll fit on the screen, but we'll stick as much as we can. Thanks, Mark. So Mark says a casing officer on a British submarine is a junior warfare officer responsible for ensuring the safe and effective execution of seamanship evolutions while the submarine's on the surface. This role involves supervising operations like docking, sailing, and other surface-level manoeuvres, acting as the commanding officer's representatives for these activities. The term casing refers to the submarine's hull or outer casing, making the officer responsible for the well-being of the exterior during operations. Fantastic, thanks, Mark. So that role is really important, but then so is the role involved in navigating the submarine. So I don't know enough. We'd need some more SMEs to be able to nail this properly. So if you're involved in this kind of thing and you want my help to learn more and make your operations and designs safer, then please send me a message. So Chris says, whilst the Nav is also a junior warfare officer, see why they get combined. Yeah. I don't know. That's one of the findings we've got. Is this a common practice on submarines, on naval vessels? Is that a common practice? And if so, have we just identified a potential weakness in the control structure of those operational systems that perhaps should be escalated and addressed? I don't know. I'm just sort of pointing at ideas. I could be getting excited over something that's actually quite basic and quite trivial, but I don't know any better, But I'm hoping I'm sort of illustrating the point, like I said on yesterday and Tuesday. When bringing the power to, when wielding the power of stamp, STPA and CAS, it allows you to ask some really powerful, perhaps basic questions that have never really been revisited before. The status quo has never really been reconsidered. And so using this approach can help you do that. Right then, so the navigation officer was nominated as the casing officer and was not able to offer any navigational advice or direction, nor take the navigation from the officer of the watch. Okay, that's interesting. I think what we've uncovered there is a serious deficiency in the control structure on the day that this happened, and I don't know if that's a common thing to happen normally. It is the view of the SI team that the responsibility for the execution of the navigation was in effect resting with the petty officer of the watch who was the only person with an understanding of the submarine's position. Okay. Well, there's the problem then, everybody. I think, that's it. We could go home now. We've found it. That's the root cause. Being sarcastic. Mark, you are making good points, Simon. Keep it up. Thanks, Mark. Well, the thing is, I just worry that I'm repeating myself too much because I get really excited about it. And then, it almost seems obvious when you start thinking about it through the lens of the control structure. It sort of emerges. It becomes apparent. There we go. Don't know if that's worked on the screen. Okay. If his recommendations to the officer of the watch had been enacted in a timely manner, they would have prevented the submarine from grounding. Ah, dearie me. Okay. That's really interesting. That is really interesting. Okay, are there any other questions or comments? And I'll just have a quick refreshment. So Chris says there is redundancy as all warfare officers are trained in navigation. The officer of the watch is often a warfare officer at lieutenant commander level, so able to navigate whilst the nav is exercising the duties of CASO. Sorry, Chris, I'm not sure what CASO is. I know what CASD is, but not CASO. Okay, so records then. So we're nearly at the end, kind of. We've got 6 and a bit pages to go. We're going to do this, everybody. We're going to do this. Okay, so records. Let's make that nice and big on the screen so you can see it. So records taken complied with the minimum expected at patrol routine. So there are various routines that the boats will operate in depending on what they're doing, where they are and what the states are. And they have to keep records depending on what those routines are. The paucity of records and the fact that 3 out of 4 electronic records contain no usable data has hindered but not prevented the SI team in reconstructing the incident. A number of recording systems unique to Astute have required BAE Systems specialists to extract the data or prove the absence of data. This delayed the SI team in finalising their report. The SI team would make the following observations. Excuse me. Okay, that's interesting. So, records. So let's just go over here, and we'll just talk generally about this then. So, when you do an investigation or when you're designing using STPA, of course, you want to know what the control actions and feedback are between the various components in your control structure, whether that's digital systems, mechanical systems or electrical systems or human beings or organizations. And that could be as basic as what is the content of an email to, what is the digital signature of that email? When was it sent? When was it received? Was it, delayed on transit? And then even down to the way humans communicate with each other, because, we can say stuff and we as the sender of that message can believe that we've said something and actually we've thought we've said something else. And I've done it a few times, and you probably have as well. You're ordering some nice food or drinks at a restaurant, and you're getting excited about what's on the menu, and you say something different to what you intended. And I'm sure there's some human factors people that can tell us all about why that is, and what the reasons are for that. But if we're trying to collect records, it's important to collect records in a way that's got some level of integrity, so that if we do need to do an investigation, we can find out what was going on and learn about how we could possibly prevent it from happening in the future. And if the capabilities to document that data are lost or corrupted or denied, something like that, of course that's a problem. So how do we overcome that? How do we set recommendations for that? Excuse me, because you might argue from a design perspective, we're designing this navigation box or this network to capture data, and it's not really that important data. The integrity of it is relatively low, so we're not going to put any safeguards in place to protect that data from deletion or corruption or getting overwritten. Whereas when you come into doing your investigation on a multi-billion-pound submarine, it'd be kind of helpful to have that data. So perhaps for investigation reasons, we increase the integrity of the design and storage of that data, so that if we need to use it for an investigation, we don't lose that valuable knowledge once it's been generated. And I could bang on about that in all different industries, because it's the same problem. It's the same problem. Right, there we go. So let's we've got some more comments. So we've got Chris says Caso is the casing officer. Fantastic, thank you. Claudio, hi Claudio, good to see you. Thanks for joining us. Thanks a lot. Well done from SCL Chile. Fantastic. Chris, is this an example of not listening to advice or acting on advice due to seniority? That is an interesting question. In the early part of the investigation report, I've seen no real mention about the interactions between individuals or their culture or anything hinted at in that way. It's been quite... so far it's not really talked about how the people interacted with each other, which is quite interesting, quite telling. Okay, so the control room fixing log. Right, there's loads of logs here, so let's get one of these and stick it over there so we can draw on it and then move it back again when we're ready. There we go. So let's just zoom in a bit. Right, so control room fixing log. So I'm going to call that a process model. And I'm going to call it the CR fixing log. There we go. Was not maintained in accordance with standard procedures, e.g. no record of fix by the oncoming officer of the watch, no chart changes recorded, no course alterations annotated, and no sounding data. Okay, so let's just think about that for a minute. Is this a physical paper log? I don't know is the answer. Is it a digital log? Quite possibly. If it's a digital log, then that is accessed through a computer system, a human-machine interface of some description. So, if there hasn't been a record of a fix and there hasn't been any chart changes recorded, is it that the recording, the logging function is faulty and they may well have changed it, you just don't have a record of it? Or was there no way, or were there difficulties, hindrances in those individuals trying to update the log? Let's say like in the healthcare environment, in healthcare IT, patient records and all that good stuff, it's notoriously difficult for healthcare workers to log into multiple different systems, all with different username and passwords, to try and get bits of information. And then also those different systems don't necessarily talk to each other. So I'm not saying that's the case here, but that's the kind of thing I'd be looking at in terms of, well, in the control structure, what is between the controller that either provides or receives that information and the log itself? Is it physical, paper, pen, or is it a digital log? And if it is, what's stopping or causing problems, perhaps, between those stakeholders? So that's the first one. There's no record of fix by the oncoming officer of the watch, no chart changes recorded, no course alterations annotated, and no sounding data. I think in the case of no sounding data, that's because the sounders were not switched on until later. So that might explain why there's no data. The ship's log. Okay, so there's a ship's log. So let's duplicate this one. That's another process model, and this is the ship's log. Ship's log, there we go. Lacked all relevant detail. In particular, it did not contain a surfacing position, no reports of major hull openings, and no report of the grounding. Okay, so I'm going to talk a little bit about this because this is concerning. Again, is it because the people involved had difficulty accessing it? Or is it because they didn't access it because they were not aware they needed to, the training aspect that was mentioned earlier on? Or what else was going on? That needs to be explained. What is the control structure around the ship's log particularly that made it difficult, or there was issues trying to update it? Now, the big thing for me as a safety engineer and done some work on some of this stuff is reports of major hull openings. And I know it's not necessarily relevant in this case, but let's imagine for a second that they'd been doing some torpedo firing on the range, and they were opening and closing doors, various doors that submarines have. You really need to keep track of whether those doors are open or closed, because if you don't, it could be very bad, and I think you can understand what I'm saying. So the fact that this log was not updated, that could be a symptom of a broader issue that might affect or indicate the potential for other accidents in the future. So that really needs to be looked at in detail as well, I think. And again, for me, it's a bit of a hobby horse, because you don't want really big holes in the submarine where you don't want them, and at the time that you don't want them. Okay, so Little Sister was started after the grounding and was only provided and has only provided limited information for the SI team. I don't know what the Little Sister system is. I don't know whether it's an actuator or a sensor, but I imagine that it provides information which becomes or forms a process model of some description for some of the controllers in the structure, whether it's a human mental model, beliefs, or some other systems. So I'm going to include that as well. And I obviously I can't talk about it because I just don't know. Right, what else? The narrative was started after the grounding. Don't know what the narrative is. I presume that that's a log of some description. Pardon me, I'll stick it there. Snaps. Excuse me. Oh dear, right, snaps. Snap. What is that? No data was recovered from the ASNAPS system. It is believed that a defect has prevented it recording any navigational data. Okay. Again, I'm not sure what that system is, and I don't want to divulge anything from my past experience on this kind of stuff. But yeah, from a control structure perspective, I'd be all over that. You know, why is this thing not recording data as needed? But again, it depends on how that fits into the control structure. Because if it's just for the purpose of the investigation, it would be nice to know this information. If it's not functionally critical to the operation of the submarine and the control structure for this particular type of hazard, then it's not really relevant to this particular case study. But if it is, then I would certainly be going down that path and asking some challenging questions. But again, it goes back to, if the system is designed for purposes related to navigation of the submarine and it's not critical to this control structure, then I wouldn't expect it to be high integrity, for example. But again, I don't want to sort of sway. I can't remember what the word is. I need some more paracetamol. SNAPS is a navigational system. Thanks, Chris. Appreciate that. We used to refer to a control room recording system as a Big Brother. I think that is mentioned in here somewhere, actually, Big Brother. Let's have a look. Yeah, there we go. Big Brother there, mate. That's where it is. Right. So Big Brother. I wouldn't be surprised if submariners had started to refer to it as Little Sister. That's probably what it is. Yeah, that is probably what it is. Excuse me. It uses integrated sensor feeds. Yeah, absolutely. Great. So where were we? So we talked about snaps. Echo sounder. Yeah, we've already got that one in the list. So Echo Sounder was started at 0628 and records only 7 minutes of data until the grounding. Yeah, okay. Platform management system. The PMS, platform management data provided by BAE Systems, has been an important source of data to enable a full reconstruction of events and corroborate witness evidence. Engine order telegraphs was not being recorded by the PMS, forcing the reconstruction to be done from shaft revolutions and directions. Okay. Yeah, again. Yeah, okay. Well, I won't want to talk about that. Big Little Brother, Big Sister. Yeah, we've already mentioned Big Brother. Sorry, Chris mentioned Big Brother, and we've already got it in the control structure over there. So I'll just stick that in there for convenience. The configuration of Big Brother has prevented any data from being provided to this service inquiry. Okay, interesting stuff. So let's just drag those all. Oh, dearie me! There we go. Drag all that stuff over there. Chuck it down the bottom, down here somewhere. There we go. Fantastic. Right, where are we? So now, oh, we're getting close to the end of this section, everyone. Oh, it's so hot in here with these lights. It's just, yeah, it's uncomfortable. I need to get a fan or something. Right then, so equipment. 2 significant equipment deficiencies have been identified. Interesting. Shall we have a guess in the chat to see which ones they're going to talk about? I'm guessing communications and data recording, navigation system related. Any more advances on those two? Don't look at the screen. Don't be cheating. So 2 significant equipment deficiencies have been identified. These are the radar 1009. Let's have a look. Have we got the radar in there? I think we have. There it is, available but not used. But it said it was significant deficiency. I thought it was available, not available. And a fragile ICS, there we go. Yeah, fantastic. So it was a good guess that. There seems to be a lot of systems not working as intended, as Chris says, and he wonders why. Well, it's because this submarine was the first of class, and it was two months, I think, outside of commissioning. There we go. So it's commissioned in August 2010, 27th of August, and then 22nd of October, less than 2 months later, this is when the incident occurred. So it could be related to that. You know, it is a complex system, and issues like that are, you know, kind of expected, I'd anticipate. Well, let's see if the report talks about it, because maybe it'll talk about that. So the ICS, the radar, it is the view. Well, just to put a point on this, so that the radar was an issue and the internal communication system was an issue, yeah, absolutely, that's certainly a contributor. But fundamentally, I'm sure from the conversations we've had over the last couple of days, it's clear that the control structure itself was inefficient or inadequate. So it's not just these 2 issues, it's a systemic issue, number of systemic issues that need to be addressed to prevent this kind of thing from happening again. It is the view of the SI team that the radar was fundamental for the safe execution of the boat transfer. Well, I suppose it is, but I'd argue it's less important than making sure the control structure is appropriate. The noise defect did not affect the serviceability of the radar, but despite him knowing that it was available, the officer of the watch did not use it. I mean, again, it's a sensor. You know, the sensor provides information, updates people's beliefs, mental models, to enable them to make better decisions. I'm not sure using that radar would have changed things dramatically in this case based on the issues with the control structure that were discussed. And recognising that the radar was available and they just didn't use it, it's irrelevant if the radar works or not if they don't use it, you know. Communications between the bridge and ship control failed at a critical moment in the incident, 0626. Okay, so I'm going to play devil's advocate a little bit here. So if you're designing an communication system, and I've had this a few times, what safety integrity do you need for your mobile phone, for example? And it's not really about the mobile phone, it's about the function of that channel of communication. If you need to communicate safety-related instructions, and let's just go back to our... There we go. So these are our unsafe control actions from our standard STPA. So if we do not provide a control action, is that going to lead to a hazard or is it going to lead to a loss, an accident? If the answer is yes, then that safety control action is safety related and it is important. And so however that control action is implemented, whether it's, hand signals, voice, winks or, light signals, audio signals, emails, telephone calls, whatever it is, whatever actuators are involved in that control action path, they need to be of sufficient integrity to make sure that that control action gets where it needs to get to when it needs to get there, or is not provided when it's not supposed to be. And so if you're designing a communication system, you're not just thinking about, a phone call, you're thinking about that whole function of communications, of that control action. And if your digital system is not available because it's, failed, or it's got wet, or whatever it is, you need to have an equivalent robust backup. And that might mean you need at least 2 or 3 different independent ways of communicating with each other. Because, of course, if your control actions are not provided at the time they need to be, and that leads to an accident, I think you get where I'm coming from with this. And this is universal. It doesn't matter what system or domain you're working in. This concept of control actions applies to anything. And the concept of integrity, if you like. And it's not about failure rates or failure modes, probability of, what's the probability of our internal communication systems failing at a critical time during the operation of the submarine? Oh, well, the amount, let's say the amount of time that you're only ever doing a critical operation on a submarine is 10%. What's the probability of your ICS that's got however many redundant systems in it failing during that small time window? What I'm here to say is that is irrelevant. Probability and failure rates are irrelevant in STAMP. We don't talk about probabilities, we don't talk about risks or likelihoods. We just literally say, if that control action is not provided with a particular context, and that leads to a hazard or loss, then that is your sign that you need to make sure your design is robust. And don't try and, bullshit yourself with arguing probabilities of failure, because this is not about failures. This is about failures and dangerous successes. And I think I've got on my hobby horse about that, so I'll just climb down now. But, what are your thoughts in the chat about that? Let's stop trying to put probabilities on complex systems, because it's getting a bit ridiculous. Right, here we go. Communications between the bridge and the ship control failed at a critical moment in the incident. Restoration took approximately 2 minutes and undoubtedly resulted in a delay in passing an engine order astern revs. Okay, so why is a communication system interfering with the passing of engine orders? Is there not some other way to do that in a robust fashion? I don't know. Is that a design issue? I don't know. I don't want to, don't want to guess, but that's certainly a question I would be asking as part of this investigation. So the SI team, it is the view of the SI team that the internal communication system requires further attention to ensure that it can support safe operation of Astute-class submarines. Yes, I absolutely 100% support that. I would be certainly tearing that to pieces and trying to understand what's going on with its architecture. And I'd also be interested to see what the system safety assessment says and what safety analysis they've done, whether it includes, nonsense numbers, 1 to the minus blah, failure rate and stuff like that. I just tear it to pieces. Damage. An inspection. All right, okay, so this is the section about damage. We should get through this really quickly because it's 2 pictures. An inspection by the Northern Diving Group of the submarine whilst aground indicates the entire hull was resting neatly on the soft seabed. Fantastic, wonderful. How lucky was that? The rudder was seen to be embedded in the silt and slight damage to the leading edge of the rudder skeg was observed. The photographs of the damage caused by the grounding show that there is no structural damage to the rudder. Damage is principally limited to the GRP skeg. I'm presuming that's glass reinforced plastic, which has been split and requires replacement. Oh, and the Butec Pinger. So Butec is the British Underwater Test and Evaluation Centre, and the Pinger is a range-provided bit of kit that you attach to the submarine, and it makes noises, and that noise is picked up by the range equipment so that the range know what's going on with the submarine. So it's for range control purposes. Estimates of repair costs have yet to be completed, but unit cost of the GRP skeg and Pinger is estimated at 81k. The RIP tow was also deployed and will need replacement. Fantastic. So that's what that looks like. It's a bit difficult to see, but there we go. And then there's another picture. Internal damage of the GRP rudder skeg. Yeah, there we go. So let's have a look. We've got some comments. Chris says, where's the button? There we go. There will have been redundancies in the comms. We had them in the 90s. I wonder if the decision was that the defect would be rectified quickly, so they did not activate the secondary system. That's a good question. I would anticipate the investigation should have looked at that, but they may not discuss that in a report of this nature, given that it's released to members of the public. Chris also says, was their situation awareness compromised in some way for that decision to make sense? Absolutely. Fantastic question. That's what the investigation should establish. That's what the investigation should look at. So great question. Thanks, Chris. Okay, so first of class issues. So we're getting close to the end, everybody. This is fantastic. All right. First of class issues. So Chris, I think this will go back to your question from earlier on. So the WEC-DIS. What is a WEC-DIS, everybody? I think that is Warship Electronic something information system. And it's not fitted to Astute, so it couldn't have contributed to this accident because it wasn't there. And as such, navigation is being conducted using traditional paper chart. Traditional paper chart procedures. It would have been nice if they'd have said that up front, actually. Whilst the observance of correct navigational planning and execution procedures would have avoided this incident occurring, a WEC-DIS system would have greatly improved the navigation or situation awareness afforded to the plot and the officer of the watch. A WEC-DIS repeat on the bridge, slave to the plot, would have allowed the officer of the watch immediate real-time reference of the ship's position and would have mitigated the lack of radar and chart. It would also have removed any discrepancies in the bridge and plot chart which were observed in this incident. HMS Astute does not hold a safe navigator laptop. Okay. So just to point that out then, so what this is saying is a piece of kit that's not fitted would have helped. And I think what it says, it sounds reasonable, it probably would have helped. But the thing I want to emphasize here is if you add this extra piece of functionality, this equipment into the control structure, that introduces its own challenges. And so whilst it might have benefited on this occasion, perhaps its introduction or its unavailability, let's say for argument's sake it was installed, but it wasn't available because whatever reason, maybe it was faulty or it got wet or whatever it is, the control structure that contributed to this accident still existed. So those issues still were present, even if the WEC-DIS might have been available. So, when we're modelling these control structures and when we're postulating how it might have played out differently, we should consider what the control structure looks like as it was, and then what the control structure might look like with these other aspects added to it. So Mark says, a WEC-DIS on a British submarine is Warship Electronic Chart Display and Information System. That's it, thanks Mark. Which is the military version of the Electronic Chart Display and Information System. Yes, it is. Now, from other experience, not related to this, I understand that those systems are not designed with the same level of integrity that you would expect on an aircraft. For some reason, I don't know why that is. Maybe the safety engineer approach for the manufacture of those systems is not as as regulated as it is in the air transport industry. And so even having one of those systems might appear to be beneficial. If it's not designed and certified to the same level of integrity as it perhaps should be or would be on an aircraft, then it might not. It might cause the accident in the future, for argument's sake. So Chris says, counterfactual reasoning, WEC-DIS wasn't there, so not a contributory factor. That should be a safety recommendation, not a contributory factor. Yes, yeah, you're right. Yeah, that's it, because this is the... this section is the analysis, contributory factors. Yes, it is. Well spotted there, Chris. Sharp eyes. Like it. Yeah, so this is... Well, I mean, it would help if the investigation report was laid out with a clearer sort of section headings instead of just bullet points. It'd be nice if it was a bit clearer how it's structured. Maybe if it had a, at the front it had a summary of the event, a glossary of terms and acronyms, and a table of contents like it is in Civil Air Transport Annex 13 investigation reports. That would help us understand it better. But yes, this is the analysis of events section. I suppose detailed analysis of the navigation plan execution and navigation records, equipment, damage. I suppose they're headings in their own right. I don't know if they're subheadings. But yes, I think you're right there. It's a good point. Okay, so Big Brother mirror, whatever that is, we've stuck that in the control structure. So this is the SI team's attempts to extract any voice recorded data from the Big Brother proved problematic. Detailed diagnostics by BAE staff identified that the overwrite security setting was incorrect, which resulted in the voice data disks being wiped of any voice data. Fantastic, well done. This shortcoming has been taken by the company for the follow-up on action on Astute and follow-on boats. Yeah, so this is a bit of a conflict between security and safety, isn't it? You know, for safety reasons, we need to record everything just in case we need to investigate. But for security reasons, we probably don't want to record that stuff. So, yeah, I mean, there's a control structure question there. Why did it make sense for it to be set like that? Why wasn't the control appropriate for doing trials on Rangers, for example? You know, because it's not as if they were out doing an operational mission. They were doing some trials. So why not, you know, record the data? I don't know. You know, it's a good question. Internal communications. So during the service investigation, a number of witnesses stated that the ICS fitted to Astute is both problematical and unreliable. Okay, oh dear. It is the view of the SI team that the ICS needs further development to ensure reliable communications to support safe operation of Astute-class submarines. This should consider improvements to the voice pipe. I think we included voice pipe over here, didn't we? Voice pipe. Where is it? Yeah, voice pipe there, look. So ICS, so they call it the... where is it? I thought we had a box for it already. But anyway, let's just stick it in there. What was it called again? Everywhere it was the internal communications system, wasn't it? Internal communications system, ICS. So that is a product of some description. There we go. Stick it over there. Yeah, so there's a question there over the control structure for the development of that equipment and its deployment onto a submarine. You know, if it was still being developed, you know, how do we, you know, given that it's such an important function as highlighted by this incident, how do we, as an organisation, say if we're designing, developing and trialling this thing or testing it, how do we control the integrity of the equipment and the test itself? Are there other things that we need to include, you know, as part of that integration effort, or was it set up as it's installed, it's all working, you crack on, go to sea, go and do your trials on the range, get on with it? You know, was it in development? I don't know. And of course, if they're doing things on the range, you know, you're already in a, you know, a higher risk sort of state. So having an ICS that's not working properly is, you know, I'd argue that should have been considered as part of the conduct of those operations, and especially doing boat transfers when you're going to be in proximity to other vessels. So again, maybe there's a trials or operations safety case consideration that should be explored as part of the investigation. That's certainly something I would ask about. Okay, so we're now on the last 3 pages, everybody. This is fantastic. We've made it this far and we've got through it. My voice hasn't failed. I'm not coughing and spluttering. So here we go. Right, so Chris says, applying logic to a military argument never works in my experience. Claudio agrees. That's fantastic. Right, well, is there any other questions before we jump into the last 2 pages? I'll just have a quick drink. Amazing. Right. So let's zoom in a bit so everyone can see this. So the findings then. Preparations for and conduct of the watch by the officer of the watch fell short of the standards required to maintain submarine safety. The planning for the boat transfer was insufficient to ensure safe completion and lacked appropriate command oversight. Okay, so why was that? What was the CO doing apart from having a shower? What was going on? Claudio says, I need more study, Simon. Don't worry about that, Claudio. I'm here to help. The boat transfer was planned to be executed at patrol routine and not river routine. So this goes back to what I was saying earlier on. When the boat is doing certain things, it's in different routines, and that means different manning levels, technology, equipment availability, and things like that. River routine would have ensured the echo sounder trace was running and manned, and would have also resulted in conscious decision on whether to operate the 1009 radar. Okay, so why doesn't the investigation before this point establish why they weren't in the river routine? Is it simply because the officer of the watch, fell short of the standards required? Well, if it's possible, because he's a human being or she's a human being, that can happen, why did the control structure not make sure that was actually set up properly? So straight away, this is... sorry, I don't mean to sort of bang on and critique the investigation and the investigators. I'm just saying that using the cast-based analysis allows you to ask these questions and be systematic in how you do your investigation, and then how you document it and write it up. So why did it make sense for them not to be in the river routine? What was going on with the control structure? Okay, a river routine would, there we go everyone, would also have river routine would also have required, the officer of watch below, they're different people by the way, to have been a seaman officer vice the logistics officer. I don't know what that means. If anyone can explain what that means in the chat, I would be very appreciative. The fact that the boat was not in river routine is highly unusual, in the opinion of the SI team. There would not appear to be any legitimate reason. For what is standard practice in other submarines not to have been adopted on this occasion. Okay, great. Why? You're the investigation team. Find out why that was the case. Isn't that your responsibility to do that? If we're going to start poking fingers at people's responsibilities, why isn't the investigation team established why it wasn't in that routine if it was supposed to be? If it's common practice on submarines, bearing in mind this is a new submarine class, if it wasn't... So where I'm going with that is, if you have a standard operational framework for any kind of submarine, which is to move through these different patrol routines, whether it's a river routine or a patrol routine, what is the control structure for making sure that the people in command of this new submarine class operate in the same way as in the other submarines? This highlights a broader control structure question about the qualification and structure of the crew, which is not necessarily related to the design of the submarine. It is about putting a new crew or a crew on a new class of submarine and making sure that they are up to the standard that you'd expect. So that didn't happen. Well, why is that? What's the recommendation there? I'm probably getting on my hobby horse again, and maybe they've answered it in the recommendations section. And it basically says go and do an investigation to find out why that part of the Royal Navy training and commissioning is not making sure that people move from patrol routine to river routine in these circumstances. Anyway, so for what is standard practice in other submarines not to have been adopted on this occasion. Again, they're on the range, don't know, it's not explained in the report. The navigation plan for the boat transfer was not briefed to any of the personnel responsible for its execution, nor was it briefed to the CO. Okay, great. So which controller was responsible for generating that plan and then communicating and coordinating it across the submarine? And likewise, why weren't the personnel responsible and the CO then going back to the person responsible for this and saying, hey, where's the brief, please? Don't know. It's not mentioned. So Chris says, it sounds as if the officer of the watch below was a supply officer and not a warfare officer. It may be an additional duty of the supply officer. At river routine with confined pilots, getting a warfare officer brings more navigational experience than a supply officer. Hang on a second. A warfare officer brings more navigational experience than a supply officer. Okay, that's interesting. That is interesting. So this logistics officer there you're talking about is, in your language, a supply officer, and they don't have the same level of experience as a warfare officer. Okay, that's interesting. So, right. So does that mean that the patrol routine, you can have a logistics supply officer who's got lesser experience doing that officer of the watch below role, whereas if you were upstated into the river routine, which is a higher level of vigilance, I understand, then instead of the logistics officer, you would have likely have had a warfare officer who is more experienced and skilled, perhaps. So that's interesting. So, and this is talking to the Royal Navy and BAE Systems designing these things. So when you do a safety assessment of the different routines, build a control structure model for the different routines and the roles and responsibilities involved, taking care not to confuse role labels and ranks and positions with the necessary functions and responsibilities of that controller in the control structure, and then look at the different routines. Because you might find, and this is not just for this submarine, but for all the others, you might find that those different routines have weaknesses in their control structures which are hidden. And until you explore it using a control structure model, you won't know that there's a weakness like this until you have an accident and it costs you, well, in this case, it was only 81k. It's not as if they lost an F-35 at 200 million a pop, but it could have been a lot worse. So, let's learn from this. Let's not have an expensive one. Fantastic. So, why was the navigational plan not briefed? Why was there no feedback about that? The execution of the plan lacked command oversight and an imposition of the normal control measures that may have prevented it. Briefing, routine, and times to be called. Don't know. Doesn't seem to be discussed. Chris says precisely that. Patrol routine is often open water, less hazards and risks. River routine, confined pilotage, high risk, lots of hazards. Yeah, fantastic. Thanks, Chris. Yes, using STPA stamp and cast to look at those routines and the control structure in them, I think would be really beneficial, really good for safety. I know I'm sort of preaching to the choir here, but personally, there would be a lot of value in that. And if you need help with something like that, please just get in touch and we can do that. Okay, so the requirement to open the SNP flaps delayed the XO getting into position in the fin until 10 minutes before the grounding and prevented early command oversight of the evolution. Okay, again, why was that? What's the control structure for that? Is it that should be written in some kind of order, a sequence of events? These things need to happen within this time frame so as not to have a knock-on effect to the navigation that needs to happen later on. The implications of landing the third seaman officer from first watch to perform the duties of fishing vessel liaison officer on bridge and casing manning were not properly considered. Okay, so when we say they were not properly considered, who or what is involved in that decision? What does that control loop look like? Who's involved? Chris says the lack of briefing of a navigation plan reduces the second set of eyes looking at the plan and highlighting risks, risk mitigation, and ensuring the proposed route is safe. Yeah, absolutely. It's always good to have an extra pair of eyes on things. Fantastic. The officer of the watch had no previous experience of operating in this area in the dark. The navigating officer was more experienced at conducting the boat transfers and should have been acting as officer of the watch, should have been acting as officer of the watch rather than being the officer on the casing. Okay, so who decided that? Why was it decided that way? Why did it make sense? The SI team considers that the most appropriate manning for this boat transfer should have been navigating officer on the bridge, second coxswain on the casing, and the TSO as the officer of the watch below. Okay. So they're making suggestions about the control structure model that should have been present at the time to potentially prevent this accident. But again, that still doesn't deal with the issues with communications. You could still have had the navigation officer up there, but those communication issues to the people below would still have been present. So would it have made a difference? Maybe not. Maybe not. You could. This is the thing. You could still have the best people in the entire world. You know, all the A players, S level players. But if the control structure is inadequate, it doesn't matter. You know, they're still going to lose. By taking charge of the submarine, the TSO had assumed responsibility for the execution of the navigation. There was no bridge chart on the bridge at a critical time. The lack of bridge chart, radar and insufficient situational awareness by the officer of the watch, combined with ineffective supervision by the officer of the watch below, effectively resulted in the control and navigation resting with a leading seaman. Okay. Radar 1009 was available if required but was not used, never used. A requirement to change the bridge ICS audio unit delayed the rigging of the secondary radar, which resulted in it not being available for use until too late. Okay. And we've not really touched on it yet, but I think it was mentioned earlier on that they had time to make up. So they were all a little bit rushed anyway to meet a time. And that's not really been made explicit yet as a contributor. Chris says, lots of could have, should have, would have, without addressing the systemic failures of this evolution. Yeah, absolutely, Chris. But again, I'm not here to beat the investigators up in their report that much. But yeah, we need to move past with would, should and could. You know, what happened? Why did it make sense? You know, people don't come to work to do a bad job and kill themselves or other people or cause £81,000 of damage to a nuclear submarine and get on the front page of all the internet newspapers. No, they don't do that. So why did it make sense? Okay, fragile bridge communications delayed the passing of an engine telegraph order. So if we think about, let's just jump to the control loop again. I keep banging on about this because this is a core concept. I want to laser etch into your minds. You know, this delayed control action, why was it delayed? What's going on in that control path? Well, it says there, fragile bridge communications, that's bad, that's not good at all. The hiatus this caused may have caused the officer watch to give a conning order in an incorrect format. Yes, of course, standard phraseology is very important, but of course, we are humans. I don't know how practiced and drilled they are at giving standard communication instructions. I don't know. Is that something they're trained? You know, if they're not trained to be that, you know, specific, I don't know. Maybe they need to be. The CO was not in the control room. He was in the shower and was unable to hear any communications between the bridge, the navigation plot or ship control. Okay. Well, again, if they're not in the control structure at that point in time, it's not, you know, if they're supposed to be, fine, but if they're not, it's not really appropriate to criticise that. There was no handheld radio on the bridge, which prevented the officer of the watch from communicating with the OMAR at a critical time. Well, I'd argue it's not that it prevented him or her from doing that. It was not in the control structure. So should it have been, and if it wasn't, why not? You know, let's not try and give credit for something they didn't have available to them. You know, again, did they recognise it was a critical time? Did they know that, oh shit, you know, I need the radio, where's the radio? Or did they not realise they needed the radio? Because they're two, the outcome is the same, but the reason and the solution for that is two different things. However, VHF was available in the control room and the wireless telegraph office throughout, but never considered. Was it that it wasn't considered, or was it there just wasn't enough time, or they didn't think they needed to do it? Again, why did it make sense? What were their beliefs? What was their decisions? The grounding emergency operation procedure is not in the index of EOPs and was not immediately apparent to the ship control team. I think I mentioned this yesterday. So if you're involved in the development of these procedures, I would recommend getting those procedures out and building a control structure for each one and seeing whether those procedures have weaknesses in them, built into them, designed into them. And that'll be a relatively quick and easy win because some of these procedures are not that big. So if you were to get one and review it, like I've shown you over the last couple of days, review those procedures, try and build a control structure model from those procedures, you might find some gaps that you can fill in and make them safer. It was the view of the service inquiry team that the time taken to rig the bridge for surface running takes longer in Astute than on the Trafalgar class. Certainly on the morning of October this was the case, as the bridge was not fully rigged until approximately 3 minutes prior to the grounding. That was 1 hour 38 minutes after surfacing. Okay. I mean, that's interesting in its own right, because, well, why is that? What is the control structure for operating the submarine safely and making sure you don't collide with things or run aground? But then what is the control structure involved in rigging the bridge for surface running? And how do those control structures interact with each other and interfere with each other? Paucity of electronic records has hindered reconstruction of the incident. Configuration of the Big Brother voice recording system meant that all data was wiped on replay. A-Snap's data card was blank due to a system defect, and Little Sister was not used until after the event. Data provided from PMS provided vital in reconstructing events. Yeah, I mean, again, that's what is the control structure for recording data? And then how is that control structure undermined by configurations of those different subsystems? Because there should be a minimum level of recording at all times, and then a higher state of recording during critical times, critical routines. That's a suggestion for the future. It is the opinion of the panel that whilst there were a number of individual and collective failings with the navigation and command team aboard HMS Astute, and these were compounded by a number of contributing factors, the failings observed are not indicative of wider failings within the submarine service as a whole. It is the view of the panel that this grounding was caused by failures. Nah, sorry mate, I don't agree with that. I do not agree with that at all. There are certainly common factors beyond just this one submarine. And I think the tone of this investigation report sort of indicates that. I think there's so much more that can be learned from a systematic perspective. I mean, the comment, where is it? The comment about standard practice in other submarines. There we go, other subs. That there is a standard practice on other subs, and that this sub takes 1 hour 38 minutes to rig the bridge for surface running. You know, there is a broader question there that needs to be considered. I don't know. That's a bit disingenuous. That I'm not particularly comfortable with that. I'm open to be challenged. Simon, you don't know what the hell you're talking about. You know nothing about the Navy or submarine operations, and I don't. But I'm looking at this through the lens of a stamped control structure model, and I'm quite convinced that there are broader systemic issues here beyond this individual submarine. I can appreciate that some of those issues might be sensitive in nature and you don't want to talk about them in a publicly available report like this. I totally get that. But I'm convinced there are more systematic issues that should be considered. I don't know, what are your thoughts in the chat? Give me some abuse if you think I'm talking nonsense, or if you've got some ideas. Of course, don't share anything that might be potentially sensitive. Chris says the skipper had a lot of trust in his tram. If he wasn't around at this time, suggests that their training had been good quality with good results. That is a very interesting point, that, Chris. So if the CO, I'm presuming you're talking about the CO, the skipper. So the commanding officer was doing whatever they were doing, having a shower. Why would it make sense for them to do that at a critical time, you might ask, as part of the cast investigation? And so if the CO says, well, I've got a fantastic world-class team on a brand new submarine that's awesome, of course I'm going to be able to trust them and go off and get ready and leave them to crack on with something important. Yeah, I trust them. That would make sense for why they behaved the way that they did. So fantastic point, Chris. Chris, I've missed the first 2 live stream. Is it possible to catch up with them? Yes, Chris, it is. I'm quite happy to stick the replay links in the chat. Stand by. Stand by, caller. So we've got... I'll give you the links on LinkedIn, actually, because then you can see the questions and comments that other people have added. So this is live stream 1. This is from Tuesday. And then live stream 2 is this one. Come on, computer. Share. Copy link. Paste. There we go. So there's the 2 live streams. These are being recorded, have been recorded, and I've stuck them on my YouTube channel. So if you visit my homepage, my website, I'll just stick that in the chat as well. There is a nice link at the top that says go to Whiteley-Safety, and then the videos are there. There's the last 2, and I'll stick that in the chat as well. Right, so before we get into the last page, and it is literally 1 page left, are there any comments, questions, suggestions that you'd like to speak about? Stick them in the chat and I'll stick them on the screen and we can talk about them before we jump into recommendations. So Chris says, thank you, much appreciated. Most welcome, Chris. I'm here to serve. Okay, so let's have a drink. See if my tea's gone cold. There we go, that's better. It is cold. Right. Excuse me. So the recommendations are made. The following recommendations are made. It is recommended that ComOps, presuming that's a Navy organisation, command operations perhaps. In fact, actually, let's just let's steal one of these boxes and then we'll add some candidate controllers that are apparent, from this page. There we go, let's zoom in a bit. There we go, so what's this called? ComOps, COMOPS. Who is that, I wonder? We'll figure that out later on, I think, unless you can stick it in the chat. It is recommended that ComOps reviews this report with a view to taking administrative or disciplinary action as required. Ooh. Yeah, no, I'm sorry, I'm not comfortable that that's appropriate. I understand, but I don't think that's appropriate. And I think that will lead to a chilling of the open and psychological safety of that organisation, those people. I understand people have to be held accountable, but if the control structure is inadequate, that's not necessarily an individual's responsibility. Who's responsible for the control structure on a submarine? Surely it's the Royal Navy or the military. Surely they should be defining it and defining the parameters within which the actual people themselves can self-organise. And I can understand that the commanding officer and the officer of the watch, they have some level of responsibility for influencing that. But are they trained in STAMP, for example? Do they think about things in the context of a control structure? Should they be? I'd argue everyone should be taught to think about control loops and control structures. But again, if their equipment's not working properly, that it's hindering their ability to do stuff, then is that really... what about BAE Systems? Should they get some administrative or disciplinary action? I don't know, maybe. The commanding officer needs reminding of his responsibilities for safety of the submarine and personnel in accordance with, I think that's the Queen's Navy regulations, I think, I don't know. QRNN Chapter 8. Again, if I was making a recommendation myself to all the Navy people that might watch this, get the QRRN out, the various chapters, and build a control structure from the content. Find any weaknesses in there, because they may specify a particular control structure that is appropriate for a certain context, but not for the context of a submarine. And so if you're trying to enforce a particular control structure that's not necessarily consciously designed, and you're trying to force it into an environment where it might not be appropriate for normal or abnormal or emergency or recovery conditions, then we shouldn't be surprised when we start having problems. In particular, the need to provide clear and comprehensive direction and guidance, and the need to ensure appropriate levels of command oversight. I'm sure they already know that. I'm sure that that's kind of self-evident. All surface officers of the watch need reminding of their responsibilities for safe and accurate execution and navigation. All officers of the watch below need reminding. Oh, these recommendations so far are not impressive. The grounding EOP should be revised and included as a separate EOP and not part of the collision EOP. Yeah, I agree with that. Clear guidance on the adoption of river routine needs to be stipulated. Okay, so that's fine, clear guidance, but why was it not already adequate? You know, if it wasn't already adequate and it's not been established by the investigation, why was that? What is the control structure? Before undertaking any further sea trials, HMS Astute should be provided with a surfaced navigation training package to cover manning routines, navigational planning, briefing and execution. Okay, so what is the control structure involved in that? Is this to say there was not one in the first place? Okay, well, why was that? Is that a Navy control structure? You know, is that a BAE control structure? Is it a combination of the two? It says over here that failings observed are not indicative of wider failings in the submarine service as a whole. Okay, so if you're saying over here that they need to be provided with a surface navigation training package, then why is that? That doesn't make sense to me. In fact, I'd argue that is quite a significant question. I'm not saying it's not needed. I'm just saying, well, you know, it's needed, but why wasn't it already there? Or why was it not already adequate in the first place? There's something else going on here that's not in the report. The fragility and limitations of the internal communication system needs addressing. Yeah. Most important is the need for 2 reliable and dedicated lines of communications between the bridge and ship control. Any solution must ensure that the CO can select and monitor these direct line communications from his cabin. I would argue that that's kind of fundamental, and it shouldn't have been put to sea if that wasn't correct. So the fact it was operating with that level of limitation and issues suggests that someone somewhere made a decision to say that that's okay to continue. So who was that, and why did it make sense for them to continue? And should those decisions change before further operations take place? I'm just asking the question, I don't know. It is recommended that WECDIS is fitted to all Astute-class submarines at the earliest opportunities. Until WECDIS can be fitted, Astute should be provided with a Safe Navigator laptop. I'm not sure that would have prevented this accident from occurring based on the control structure issues that we've identified. But it's an interesting recommendation, and at the time this was done, I don't know why it didn't have one in the first place. And I don't know. I don't know the history or anything like that. So, but again, if it didn't have one and one was available, as it seems to have been, then what was the decision not to fit it? Why was that decision made? What was the explanation for that? That might be a Navy question. They might have said, "Oh, well, we haven't got enough money," or we don't think it's necessary. We've never had one before, so why do we need one? So I'm playing devil's advocate, but I'm sure you can see what I'm getting at. And then finally, the last one, shortcomings noted in the operation of Big Brother system need to be rectified at the earliest opportunity. A full brief of data capture and playback procedures needs to be provided to ship staff. Okay, why wasn't that provided in the first place? Again, is that a Navy question? I don't know. Right, so that's kind of it. I think we've got enough there to be getting on with. You can see that the control structure is a bit of a mess. So between now and next Friday, when we're going to do the live Zoom workshop, so please come along. In fact, what I'll do is I will get on the screen the link to join. So I'm organising a Zoom meeting for next Friday, and I've set it at a time which will enable as many people from across the globe to attend as possible, so that everyone can share their experience and build a network together. And let's just copy the link. Let's see that it works. Yes. Right, so here's the link to join next week. So click on that link, stick your email address in there. I'll send you a Zoom link so you can join. We'll get together live on Zoom, so you can come up on your camera, get your microphone out, shows you handsome, attractive faces, and we can talk about the issues, talk about your experience, talk about STAMP, STPA and CAST and how to do it and any questions you have. And of course, we'll be doing it in the context of this case study. And I will, make this control structure look a bit more pretty. I'll keep this one as it is, so that you'll have a memory of what it looks like when you've seen it on the live stream. And then I'll create a fresh one that looks a bit more tidy. There will be gaps in it, and there are gaps because there's not that much information in the report that would help us build a complete model. And of course, my experience, I don't have enough experience about operations of submarines to really discuss this, but I will add some things to this and tidy it up. So yeah, let's just have a quick look at the chat, see what else has been put in there. So Mark says, the IS team may be looking at the fact that other submarines have older things Astute did not use, so no worries. Of course they would use them. Of course they would use them. Yeah, absolutely. I mean, there's a touch of hindsight bias there. I'm not particularly impressed with the tone of that investigation report. I certainly think there are other things that they could learn, and if they were to use the CAST-based approach, build themselves a control structure and look at the higher levels in that structure, noticing that there isn't really any mention in the report of those organisations, then yeah, I think they could find things that they need to solve. And of course, I'm available to help solve those problems. So if you're involved in that kind of thing and you want some help, please send me a message and we can have a conversation. Chris says, QRRNs are the Queen regulations for the Royal Navy. Nicely done, Simon. Thanks, Chris. I really appreciate your input. That's fantastic. Chris, I bet the CEO didn't need reminding of his responsibilities after this incident. Absolutely. It's James Savage. If having a handheld radio to hand should have been SOP as it seems from this report, then it surely should be represented in the original control structure. Yes, absolutely. Now I have included actuator sensor VHF radio handheld there, and I've not placed it between. There you go. So there's the MV Omar you can see. So that radio, you could argue, should fit between there and there. But because it wasn't on the bridge, it's kind of academic, really. So when I tidy the control structure up, I will include it, but I will annotate it to say that it's not actually present in the real control structure. And had it been present, things might have been slightly different, but I don't think it would have prevented the accident itself. I think there were too many different things going on across the control structure, and because of the time delays and such like, I think it was almost inevitable. So there's my website. Oh yeah, so if you want to join me next Friday please click on that link, register, and we can have a great time. Make sure to bring your refreshments and snacks. And Mark says, thank you, Simon. Another good day, Simon. Thanks. Thanks, Mark. It's always great to see you. Thanks for coming along. So that's everything. So I hope that was helpful and useful and interesting. If you really like that, please like the post, like the live stream, share it with your friends and colleagues who might benefit from it. And of course, if you've got any questions or you want to have a conversation, please send me a message or visit my website, send me a message and I'll set a call and we'll see how I can possibly help you. So thank you so much for attending and all your attention and your passion and your contribution. I really appreciate it. And I'll look forward to seeing you next Friday. Take care. Bye-bye.